We can also use limits to investigate end behavior of a function. Recall that end behavior is what's happening to a function at the extreme values for x. So as x gets incredibly large or incredibly small. Our answer is going to be either that our function can be headed off to positive infinity, negative infinity, or approaching a specific number. In the case of example 4, we want to consider the limit as x approaches infinity of n of x. We're going to consider a similar idea to what we had before. We're going to trace along our curve, but now instead of x approaching a specific number, we're considering what's happening as x just continues getting larger and larger and larger and larger. So we're tracing along that graph towards positive infinity. And we can trace along the graph for part B towards negative infinity. And what's happening in both cases is that our curve is going to be approaching a function value of negative 2. So the limit as x approaches infinity will be negative 2. The limit as x approaches negative infinity will be negative 2. And what that kind of goes on to further mean is that our function has a horizontal asymptote of y equals negative 2. Because as we consider those extreme values, our function value is getting closer and closer to negative 2. That's going to be different than the behavior that we see in examples 5 and 6. Now in example 5, for part A, we want to consider the limit as x approaches infinity. So again, tracing along that curve towards positive infinity. That's just going to continue increasing up and up forever, so that limit will be positive infinity. And as we consider the limit as x approaches negative infinity, so tracing along our curve in the direction of negative infinity, we're again headed up to positive infinity. So at both ends, this curve is headed off to positive infinity. In example 6, similar problem, but now we're going to see some slightly different behavior. In this case, as x approaches positive infinity, our curve is headed down. Our function values are getting smaller and smaller. So as x approaches infinity, our function value is approaching negative infinity. And as x approaches negative infinity, our function value is getting larger and larger. So our function value is approaching infinity, positive infinity. In the case of both 5 and 6, these functions do not have a horizontal asymptote, because a horizontal asymptote only occurs when our function value in the end behavior is approaching a specific number as it heads to the left or to the right, or in the case of example 4, in both directions.